What's up, boys and girls, and welcome to your very final sixth grade math lesson on area of polygons. Today we're going to be talking about the area of the shaded region. So you'll need some supplies, of course. Get a pencil, get a notebook or paper to work along with me. A calculator will also be helpful, so grab one of those. And if you still have access to, make sure you have your formula sheet ready to go. All right, let's jump right into our first example. So with these examples, we're going to be asked to find just the area of the shaded region of the figure. So if you look at the shape down here, the shaded region is almost like a border or a frame around a rectangle. So what we're going to do, I want you to envision that this entire shape is completely filled in, like it is one big solid rectangle. And I want us to find the area of that first. If you need to, pull out your formula sheet. Area for a rectangle, the formula we should use is area equals length times width. So let's go ahead and for the shaded region, calculate the area as if this polygon was completely filled in. Area equals length times width. So of this entire shape of the big rectangle, the length is 11 times the width is 8. And I'm going to perform my calculation 11 times 8 to get an area of 88 square inches. But that would be the area of this polygon if it was completely filled in. We have a big hole in the middle. So let's find the area of this missing region. Well, the missing region is in the shape of a rectangle. So I again am going to use the formula for area of a rectangle. Area equals length times width. Now the length of our missing piece is 9 inches, and the width of our missing piece is 6 inches. And when I perform my calculation, 9 times 6, I get an area of 54 square inches. Now let's take a look at our work so far. This large rectangle, if it was completely filled in, it would have an area of 88 square inches. But there is a hole inside, and that hole has an area of 54 square inches. So to find the area of just the shaded region, or what's left over, I'm going to take the area of the entire object, and I'm going to subtract that missing piece, that hole in the middle. And I get an area of 34 square inches. So just the shaded region, just the border, covers an area of 34 square inches. Okay, let's try another example together. We have another irregular figure on the screen. Now you could, from our previous lesson, come in and cut this into 3 different rectangles, find the area of each rectangle and add them together like we did in a previous lesson. But today we want to practice calculating the area of this object as if it was a solid polygon and then subtract the missing piece. So first off, if I made this one solid piece, I can even draw the line to make it complete and filled it all in, I would have a rectangle that is 12 centimeters by 8 centimeters. So let's find the area of that rectangle as if it was a solid polygon. So for our rectangle, area equals length times width. The length of our rectangle is 12 centimeters times the width is 8 centimeters. 12 times 8, we get an area of 96 square centimeters. But we got a chunk missing in the end. So let's find the area of that missing chunk. That piece that's missing is a square. I know it's a square because it's a quadrilateral with right angles and all sides are going to be the same. So formula for a square, if you need to pull out your formula sheet, the square is the third object on the left-hand side. We see area equals side length to the second power. So let's copy down our formula for area of a square. Area equals s to the second power. The side length of this square is 4 centimeters, so I'm going to plug that into s. And now I'm working out my formula. 4 to the second power means 4 times 4, which is 16. So that missing square at the end of our rectangle has an area of 16 square centimeters. Well, now let's just find the area of what is remaining in this rectangle. If the rectangle was solid, it would have an area of 96. We're going to remove the 16 square centimeter square that is missing to give this shaded region an area of 80 square centimeters. All right, let's do one last example together. Again, we're trying to find the area of the shaded region. So my first step, envision this as one big solid triangle. What if that triangle was completely filled in, completely shaded, one solid triangle? Let's find the area of it. To your formula sheet if you need to. Triangle is the very first polygon on that formula sheet, and the formula for calculating the area equals 1/2 times the base times the height. So copying down our triangle formula, area equals 1/2 times the base times the height. Starting to fill in our values, we have 1/2. The 1/2 is touching B, means we're multiplying. Now I need the value of B, the base of the triangle. The triangle, the base would be this bottom side here, which is 10 meters. Times the height of the triangle. How tall is the triangle? That measures over here on the side, 15. So now I'm calculating 1/2 times 10 times 15, and I should get an area of 75 square meters. Now that is the areas if the triangle was completely solid. We're missing a piece in here. So this middle piece that's missing looks like we have a square because the sides are the same. So from our previous example, or if you need to look it up, we know the formula for area of a square is the side length of the second power. The side length of this square measures 5 meters, so I'm going to plug 5 into S. And working out my calculation, 5 to the second power, 5 times 5 gives us an area of 25 square meters. Now, one last step, don't forget to do it. We only want the area of the shaded pieces. So I'm going to take my entire triangle that had an area of 75 square meters. I'm going to subtract the missing square that has been removed from this triangle in its area of 25 square meters to get a shaded region remaining of 50 square meters. Okay, boys and girls, I got 2 for you to try on your own. Go ahead, pause the video, find the area of each shaded region. When you're done working, go ahead and resume playing to check your work to see how you did. All right, boys and girls, let's get to it. Let's check your work. First off, I'm going to start with one large triangle. My formula for a triangle is 1/2 times the base times the height. 1/2 times the base of this triangle is 10 times the height is 13. So 1/2 times 10 times 13 should give us, let's pull out our calculator just to make sure we're not making a mistake. 1/2 times 10 times 13, 65. We have a missing piece. This missing piece is in the shape of a rectangle, so let's find the area of that missing piece. Formula for area of a rectangle, length times width. The length here is 8, the width is 5, and 8 times 5 gives us an area of 40 square inches. So to get just the shaded region of this object on the left, we take the triangle's area of 65, subtract the missing rectangle, and we get a final shaded region area of 25 square inches. All right, last problem on the right here. First off, if I filled this entire object in, I would have a rectangle, so area equals length times width. The length of this rectangle is 15 times the width is 8. 15 times 8, you should get 120 square feet. And now I want to find this missing piece. It is a triangle, so formula for a triangle, area equals 1/2 base times height. 1/2 times the base of this triangle would be this missing side here. And because it is also a side of the rectangle, I can gain that measure by looking at the opposite side of that rectangle. So the base is 8, and then the height, how tall is the triangle from the base to the opposite vertex? That measures right here, 7 feet. So 1/2 times 8 times 7 should give us 28 square feet. And now to get the area of just the shaded region, take our rectangle, subtract our triangle, and we should get a final area of, gotta borrow, 92 square feet. Boys and girls, make sure you complete the independent practice assignment associated with this lesson. Take a picture of your work and upload that file for submission. I'll see you guys next time.